So welcome to the lathe sort of orientation, whatever you want to call it, the first part of the thing. The idea is at the end of this you'll know what a lathe is. So those of you who've come along expecting it to be deep and dirty, you might be disappointed if I'm honest. So basically we've got the lathe now, it's now operating. I'll go through a few of the features of it in a minute. So let's just start. So, right, first thing, lathes. Don't do it if you don't know what you're doing. Basically, you've got something that's capable of throwing anything that's not attached in a sensible method, either at you, through you, whatever. Plus, it's rotating at speed, so if you touch it, it's going to hurt. Top tips, don't ever look up the accidents. It will put you off your cornflakes.
Or ever wear a tie near it.
Oh yeah. Well, all of those are covered. If you look it up, look up health and safety and ROSP or something, and just yeah. But obviously, we have to have this thing where we've got a restricted use policy on it. It is secured by a lock. It's one of the few things that is. Please, just honour that. It's not going to be truly enforced, but it's kind of one of those things where we need to do tests that people are okay, and we need to make sure that we don't get sort of people who aren't capable using it. So to prove you're capable, there's a test piece that we'll come to more details on, which you can turn out in aluminium, which is the sort of the free of charge, easy to do version. The brass, which is actually no more difficult to do, it's just different to cut. So I definitely would recommend doing the aluminium one first, and then coming back and doing the brass one if you want a brass one. The brass one has the advantage it actually works properly as a plumb bob, because it doesn't. This one doesn't really weigh anything, so it's a bit wobbly.
What is a plumb bob? Because I just think of the seams.
A plumb bob is a way of getting a vertical line using gravity, basically. So you hold something and it just drops. And, yeah. Yeah. Right. So there we are. There's the pictures of the plumb bob. So you can have it in the silver, aluminium, or the lovely brass. So there's our lathe. That's the one around there. There have been a couple of updates to it that aren't on that picture, which includes some of the extra safety systems that have been put in. I'll come to those in a moment. Right, so what does it do? It spins up a piece of metal and allows you to cut it in a symmetrical way. The actual material doesn't necessarily have to be symmetrical. It could be square or hex form or whatever. But whenever you cut it, you're always going to wind up with something which is round or a round shaped item afterwards. So you're cutting around the outside. Exactly the same as a wood lathe. So you think of it as turning a banister rail or whatever. It's doing the same thing in metal. Our particular lathe has a 3-phase motor in it, which is currently used as an inverter to allow it to be controlled from our domestic supply, because we only have a single phase supply, which has several advantages from the point of view of maintaining speed and being speed adjustable, and also being able to easily reverse the lathe if you need to do that, which you don't normally need to, but it can be handy on occasions. In addition to that, we have quick release tool holder, we have boring bars and various standard cutters, and we have some extra chucks. I'll come back to the individual cutting tools in a moment, but we do have a selection of tools, most of which are tipped tools, so you can change them so you don't have to know how to grind, which is very helpful, because normally you have to grind the tips if you want to cut anything on a lathe. So, is that done too? Or is that one? Right, okay, so that's our thing. We've got various bits. Unfortunately, you can't quite read the size. I've got my sizing wrong there. But obviously you've got the chuck, which is the bit that goes round. You've got the headstock, which the chuck is within, which is like, we've got them here, you can see them. So this would be our headstock. This is our chuck down here. And then we have the speed controller, which is the blue box, which would be again on here. And we have an emergency stop bar, which I'll come to in a minute, which you have a stop button on here. And forward and reverse and various other parts to it. You've got the saddle, and you've got the slide, which holds the chuck. This is the saddle over here, and then you've got the compound, as they call it, which you can set angles on. So this is the main winding gear. Basically, this is exactly the same. you've got the carriage wheel, you've got the tail stock, you've got the tool holder, and the compound slide, which is one that does the angles, and then you've got the cross slide, which goes in here, which is cross control there on the end. Yeah. So there we are, a bit more detail on that. So there's the tool post in the centre, which on this one is obviously here. This is a quick release one, so you can change the tool very easily on the tool post. The tools, each tool is held within it. Again, I'll show you more detail in a moment. And this is the various bits you can adjust. So you can go across the bed using the carriage. You can also go at an angle or across the bed with the compound. And you've got the cross feed, which takes you across the lathe. So if you were trying to get on the end of a piece of metal, you'd wind yourself into position, and then you'd use the cross feed to cut the end smooth of the thing. If you were going down the side, you would normally use either the carriage, or you can use the compound under some conditions as well. One of the things I'll highlight here is that you'll notice there's a stop that's just here. That is probably one of the most useful things on there, because what that allows you to do is it allows you to cut, particularly on the plumb bob, it allows you to cut up to an edge, because obviously you've got to machine this down from a solid piece, so that repeats it, so you can just keep going down to that till you get the right size. And because you're going against the stop every time, you don't have a wibbly wobbly edge on there. So that means when you put the two bits together, he says, when successful, you should have no gap, or very little gap. Yeah. I'd love to say no gap, but that would be, yeah, that would be a bit too optimistic. Okay. So again, we've done that already, but I'll do it again. Moves fast, throws things around, don't have anything loose. Make sure you've got no cuffs or anything that are doing stuff. We do have the advantage that there are some safety features which I'll come to in a moment, which will help you. Always use the guard or wear eye protection. Particularly that is if you don't wear spectacles. If you wear spectacles, with just the spectacles and the guard, the drop down guard, you should be good. But if you're going to do it and you're going to look around the end and start machining holes and stuff when you're looking around the edge of the thing, I just recommend that you wear a set of safety specs, particularly if you're cutting brass. Because although some of the other metals will spin out with long big streams, the brass comes out in little tiny chips and tends to go a bit all over the place. So you're looking very scared there, Sarah. Okay, and always know how to use emergency stops and check they're working. Always check they work before you start your session, just in case you need them. It's a sure guarantee you won't, by making sure they... Okay, oh. Yeah, again, never use dangerous materials or techniques. Assuming, as I say, if in doubt, don't do it. So, what have we got? Well, there's been a couple of upgrades since last week, which you may or may not have noticed. We've now got an emergency kick bar on the bottom there, which has been made with a couple of foot switches. So basically, if you kick that, it will take the power from the lathe. There's no brake on this lathe, so it will take time to spin down. So just so you know, but it will stop it from hopefully doing too much damage. Secondly, there's a safety guard interlock which has just been fitted, which may look a bit old and painted. That's because it came off an old alarm system. But basically, if that's not in the down position, then you won't be able to spin the motor up to get the thing going. You can still perform various manual operations with the guard up, which we'll come to. You'll see them. Some of those being done when we do the threading. The threads that were put in here were put in by hand with taps and dies, rather than cut on the lathe, which is a very complex operation, sort of like level 3. And we're only doing level 1 because I'm not capable of showing you any more than that. Okay, so moving on. So as I say, we've got an inverter, controls the speed. It's got a rev counter, which will show you the speed you're going at, forward and reverse. There's now another button here which is to do with the safety system, and a little green LED that's up there which proves the safety system's working. So obviously most important, remember to take the chuck key out, okay, because it hurts. Now the other thing that helps with that is the fact you've got to put the guard down. Okay, so that does make a difference. Secondly, the inverter has a slow spin up, so the chances are that it will rotate slow enough that it will drop it out or catch on the bed and stall the inverter. Both which hopefully that won't throw it at you. But obviously kick bar should you need to. The other thing is the kick bar goes around to the end of the lathe, so you can operate it even if you're ducking out the way, you can still operate it without them to be stood right in front of it. Also, someone else can put their foot in and just kick it if they need to. So.
I'd imagine you do that automatically because your body goes into shock.
Yeah, I suppose so. If gravity's you fall on it will probably do the trick, but just be careful in your aim. That's all I'm saying.
An extra switch at the back that you fall against as well.
Ah, maybe. Well, that'll be part 2 of the emergency system.
Upgrade.
Anyway, yeah, we're gonna have something to upgrade to. So, tools are mounted on a Boxford quick change tool holder, which again, one of the advantages of that, it means you don't have to change the height or reset the height. They're all already set for you. Because normally that's a real pain. You have to undo all the screws, change the tool, pack it out to get the centre right. And as you grind down the tool, you actually wind up with the centres moving. Well, all of that's taken care of by the thing, so you don't have to worry about that. Now, obviously there are various different operations you can do. A facing operation where you cut the front off of the material, or flat straight turning, taper turning where you put an angle on it. So for example, like the plumb bob. Contour turning, which there's none of that on that because that's a grade 2 or 3. Forming, which again is you cut a custom tool for. Chamfering is more likely, you'll be likely to be doing that. Passing off, you'll definitely be doing that. Threading, as I say, that's a level 3. Boring's a level 2. Drilling's in the first level, and knurling is kind of what we were doing in level 1. So we have tipped tools here. So one of the advantages of that is that you don't have to actually grind the tips. We just change the tip when it gets blunt, which means you don't have to be able to get all your 5-degree angles and 10-degree angles and stuff and your leading edges and stuff and worry about all that stuff because it's all done for you. So, which is great because it means I haven't got to teach any of it.
That is a
Not,
great boom.
it is. It is.
It's a great boom.
It takes it from something you can't do to something you actually relatively easily can do, and saves about what? How long do you reckon it took you to learn to grind a tool, Chris, when you were doing your mechanical? 3 months, and probably was still bad.
It's still shaky there. Yeah, that's all we need.
Yep. Okay. So the things we don't have, we have a standard part and off tool, so that doesn't take tips, and we have some tip ones as well. So they may need to be changed, but we'll worry about that later. Okay. So the quick release tool holder, very simple. You just twist it, the tool lifts off, and you see, so the tool's already set on all of these, locked in with those 4 things, and this will adjust the height. But the height's preset and then locked in position. So as soon as you drop it back on, it goes back to the centre of the work. You can carry on. So it means you can just change tools when you need to without having to worry about it. And trust me, it really makes, oh, it's lovely. It means you can turn up one of these in 2 hours.
Yeah, and you don't have to fiddle around with lots of little tiny
Yep.
sort of 0.1 millimetre thick
Shims and
metal
yep,
shimming.
yeah, all of that. Yep.
I'm assuming you've had experience the other way.
Oh yeah, I've done. And Mark's probably got recent experience of that.
Those in my day.
I can hear
No.
the relief in your voice.
Oh, absolutely. I'm look. When I saw that lathe, I fell in love with it. Right. So there's our various quick release tools that we've got available. We have got some other. There are other quick releases, but they're with standard tips, so I'm not going to deal with those at the moment. So there's the knurling tool, a rounded profile tool, a parting tool, the right hand finishing, which we won't be using, and a standard finishing tool, or cutting tool if you prefer. Now, one of the other things to remember is you never want to go too quickly when you're cutting. One of the problems, particularly, we don't have lubricant enabled on that system because it's very messy and it causes lots of problems. So whilst you can put it on by hand if you need some, one of the things I recommend is run slow, particularly to begin with, because otherwise you don't get quite as good a finish. I have to be honest with you on that. it does mean you don't get the heat building up, and that can cause other problems to do with expansion and all kinds of other things that happen within the thing. So my recommendation is stick to the lower speeds. At the moment, I think the top speed it's doing is about 600 RPM on there. We can increase on the belts if we need to go higher than that, but I'd say most of what we can do at those sort of speeds. It might be 650. We're doing mainly cutting aluminium and brass at the moment. They're the things to begin with that we're aiming to get everybody trained on, because they're considerably easier. They don't cost the tools, the damage for a lot of people to learn on. So they're much nicer and easier to work with when you're first learning. Unlike the steel that we had to start with, chiseling it and stuff.
Swarf isn't painless.
Sorry?
Steel swarf isn't painless.
Well, aluminium swarf could not be painless as well. It's less. Not wishing to challenge. I don't want to take on that challenge of who can do the most damage with aluminium.
You're not going to swapping scars, are you? Call that a scar.
Anyway, okay. So, I mean, typically, say we want to do the knurling at maybe sort of like the lower speeds, about 300, maybe even a bit slower than that. The slower you run, the easier it is to see what's going on. Knurling is a bit of a tricky thing to get right, to be honest with you. You've only got to look at those and discover that I haven't quite remastered it yet. So I'm hoping by the time I've trained a few people, I'll have the hang of it.
You'll be able to make yourself a lightsaber handle for when you do your training.
Aye, I'm hoping it's going to come with a handle. Yes. Okay, so in addition to the cutting tools and things, we have various tools that go into the other end of the lathe, into the tailstock. So we've got, which is that bit, so we have a chuck that will go in there. We also have centres, so if you've got a piece of material that's likely to be moving out of centre when you're doing some operations on the outside of it, then you can drill a little pinhole in the end of it, or a small hole, and put either an active centre or a passive centre in there just to hold it, to stop it from moving, to get you a nice parallel. Again, not something we'll be doing on the sort of level 1, but is something that is available. We will of course be using the chuck. We will be drilling during this, and we'll also be using some thread cutting capabilities within it, which is not the normal way you would do it. Normally, in an ideal world, you cut everything on a lathe with the lathe tools, but threading is particularly complex, and you get it wrong, you ruin the job. So we're just going to use a tap on the die, which is nothing. I know lots of people who, all the amateurs I know, if you like, and the model engineers and stuff like that, that's how they do the majority of their thread cutting. They do cut.
It's like the winding thing.
Yeah. They will cut with a lathe if they have to, and particularly if they're looking for very large size sort of threads and stuff. If they're cutting a 2.5 inch sort of thread for something thing. I mean, if you go down and see the model engineers, they're just mad. They cut ins for boilers and all kinds of stuff. But I'm just constantly in awe of some of the stuff they produce, and you just go, how did you do that? Anyway, so the maintenance, there isn't really any maintenance that we're actively getting members to do at the moment. We're going to do that. There is some oiling and stuff and grease that has to go into the grease journals. But again, be very careful with the swarf. There's a stick, a wooden stick there, which sometimes you need to use just to get stuff off the tips and stuff. Again, if in doubt. Now also we've got the responsible members. There's just the 2 of us at the moment. I'm hoping there'll be some other eager volunteers. Oh, I didn't see any hands there. Okay.
I've got an AUD, so I might help.
Ah,
You've got the CUD.
yeah. Ah. Right. We've got some various bits to do, electronic versions of documents and stuff like that. Again, just ask about it. There's also this Boxford booklet on Know Your Lathe, which is available at that address, which I think is in the manual as well.
It's also
in the
on
book.
the shared drive.
It's also in the shared drive. Okay. Which is just a general, quite detailed document that covers the AUD, the UD, the CUD, and various other Boxford lathes. It's not the best copy in the world, but it's pretty good. But the stuff Steve's done is actually.
This is the metal lathe book.
Yeah.
You can see it.
You can see that's got much more detail in it, or as much detail, and nice colour pictures, and it's all about our particular lathe rather than another lathe. Okay.
Looks nicely done.
Boxwood will sell you the complete set of maintenance manuals for £78.
Oh, there we go. There you go. Yeah, that's possibly even worth considering. That means, but the trouble is, if they sell them for 78, somebody must have ripped them off for 48.
Hello.
Anyway, so the plumb bob, we've got the various operations that are needed to do it. So you're going to put the material in, you're going to do the various things, stuff like that. You've got the various techniques that are needed, and so you've got knurling and stuff like that. So what we can now do is we can now actually.
So the plumb bob's specified on this sheet
Yep.
of paper here.
So there are a few challenges with that. So I suspect anybody who's doing the training or wants to do the training, I should say, pay particular attention to the next few minutes. Okay.
You need to click
Yep.
on the player.
So there we go. That's putting in the material, checking the material's got the right amount.
It's moving fast.
I'm
Careful
I'm
now.
quick, checking the tool's square.
It's they move fast and break things.
So that's the facing off operation.
So this is facing off meaning
Getting flat on the end.
Yeah.
And we're going to parallel turn down the side here, so I'm just marking up where I need to parallel turn to. So that's up against what I've done at that point is I'm using the stop to make sure that I can't drive it accidentally into the chuck. By working close to the chuck rather than by having it out by a long way, it minimises the amount of vibration and movement you get. So it makes it much easier to do that without a centre, because obviously we don't want to work with a centre. So again, what I'm doing is I'm scrolling up against this stop. So each time, so I know that I've got the right thing. So I'm just checking that and marking my depth. And I'm going to centre up. This is a centre drill. I'll spin it up again. So, nifty trick, using a bit of tape to mark the drill depth that I want.
Does it have markings on the tailstock?
It does have markings on the tailstock, but you've got to calibrate everything and get it all correct. If you mark it on the drill, you can see it.
It touches that you want
Yeah.
it in the right amount.
Exactly. You can do it either way. I've got no problem. But there also we've got an old mechanical caliper which we can push in. Which
It's not the one I left round here, was it?
it
That's
is.
rubbish.
Probably it is because it's rubbish, but it's perfect for that.
It's actually because when you're putting the thread on, it's just got to be
Yeah.
close-ish.
Yep.
Might be worth us ordering a proper one at some point.
So, well, we've got a regular one, but unfortunately it's got a square. That one's got beautiful round because it's cheap. It's got a round tip that just drops in.
Where did you get it from?
Probably pound shop or something years ago.
Sounds like that.
I've got a little digital one. I've got two. I bought one because it was
I
broken.
think we had one round here as well.
So what would
But
you
so
use?
can
it
I.
for?
How much
Yeah.
are you incrementing how much you take it? What's your depth of cut?
About point one of a mil, 0.2 of a mil each pass.
So you're taking off about 0.1 or 0.2
Yeah.
millimetres every time.
Yep. So obviously I've skipped some. This isn't a true representation.
So short
But
bursts
yeah,
to
it-
avoid heat build up.
Yeah, well, to be honest with you, when you're only cutting small amounts, you don't have any heat build up particularly anyway. Aluminium and brass both conduct quite well. So
But
again,
if you had the pedal down, so to speak, constantly, it would, wouldn't it?
It
So
would,
by-
it
by
would.
doing it a little pulsing
Yeah.
movement.
so here we're going to clamp. Here we're clamping the actual chuck, which is one of the easiest ways to do this. We have got a stop on there, but the stop's only really designed for reversing the gear and stuff. So it's not really what you want to do.
And that's using the
So-
die.
So that's the die. So the dies we use out from the set,
Oh,
and
I
then
see, right.
that's cut that. So we run it off of a piece, and there we go. Tested it with one of these things to make sure it fits. So what we've done is there's a nifty trick you can do there where you run a piece of studding up against it, and by doing that you feed straight off of one straight onto the other. So you haven't got to pick up the thread like you normally would. So that's a top tip for
And you just swap the
Yeah.
tool there.
Oh yeah, sorry, I've just swapped to a parting off tool, and what I've done there is I've just put a little mark, just a nick in it. I've not actually done it all the way through, but it's to give me an idea of where I want to put the knurler. It's much easier to look over the top and adjust it. So you just adjust it, spin it up a fraction, and adjust it and spin it up a fraction until you're happy. And then when you're done, there we go, you've got your knurl. Then you put your parting off tool again. And you cut that down. Obviously, please remember this is speeded up. Do not attempt these operations at this speed, because I'm not fixing it.
Fast-fingered Freddy.
Yeah. So that's sorted and that's come off. We've got that.
The other
We'll
thing to
face it
note
off.
there is that because it was drilled, you're not parting off all the way through.
Oh, I see, yeah.
Yeah.
That was me.
Yeah.
Foolish.
Well, no, later on we do a part.
Yeah, yeah, we do it the other way. Okay, so there we're going to, again, same thing, position it, doing a depth, cut to depth, then we change it for the bigger drill.
See the all the little chips there.
Yep.
It's,
This all looks a bit like a cooking program. Here's a drill I
Yep.
prepared earlier.
Yep, exactly. So that's just checking the depth. Just cleaning out any rubbish that's in there. Again, checking the depth. And then we mark on the thread so we know the depth so we don't overrun. Again, you can do it till it locks up, but rather than risk taking the thread out, easier to put a marker on it. Again, clamp it. Obviously, make sure you remove the clamps before you try and start the lathe. So this is a taper tap that we're putting in to begin with. If you just release, what I've done is release the stock, so the tail stock, so I can just wind it out without having to worry about it. And then I'm just using.
It's like lathing Benny Hill style,
It
isn't
is. It's it. High-speed lathing. So again, I put a tap on it, just making sure I'm going the right length. Making sure we've got plenty of spare. So that's it. Pull that out. And again, run it in till we're happy. You're never going to get it exactly to go in at that point because you need to counter bore it, because there'll always be a bit you can't do on the top of the thread. So this is where we counter bore it, just a little bit of, just about 3mm, 4mm in. That's enough, and then clean it out, and then all of a sudden, I had to clean the thread up as well. Sometimes you have to do that, and then it goes right in. So just clean that tip off. Just put a very slight chamfer on them. Yep, there you go. Foot fits. Then we take the centre off of that, and just face it off so it's nice and smooth. And we just put a small chamfer on the edge of that. Checking our position for our. So you can see I'm stopping it and then tightening it and just checking which one my head appears over the top. You don't really want it. Ideally, you don't want to take it off and reposition it afterwards.
Are you only doing a single rotation?
No, you're just putting it up for a few seconds and just
Okay.
just spin it up and just as soon as it starts going up, just take it back down. You only need to do a few
But you
rotations.
don't want to do too many rotations
No,
because
I
it'll.
understand that.
And then again, cut that for length. And now what I've done there is I'm waiting until it's weak, and then when it's weak, I break it. And the reason for doing that is I don't want the thing flying a large lump. The little bit which is threaded, it's not too bad, but this is quite a big chunky piece, particularly if it's brass.
Okay.
And then this I've wrapped this in a bit of a milk bottle container, and this is to stop you destroying the knurling that you've put on the other end. But you have to clamp it down, leave it, clamp it again, leave it, clamp it again, because you'll find gradually the it gives way. So this has now been set. The compound's now been set to give an angle, 25 degrees, 26 degrees, and then so just taking that off. You'll notice I've taken off the last piece of the thing. I've just faced it off roughly. The reason for doing that is to make sure that our dimensions are correct at the end. So again, we just keep going backwards and forwards.
So when you're using the compound, is the stop working or are you?
No,
No.
it's up. Well, it's up on the stop here.
Yeah,
I've already got.
Paying close
you're having
attention
to pay
to
close
the shot.
attention.
You have to pay close attention. Yeah. Yeah.
That's what I thought.
Yes. If you get that wrong, there'll be an almighty crunch.
We went first.
Yeah.
I was just double checking there
Yeah.
wasn't something on different.
Do you not have a collet set?
Sorry.
Do you not have a collet set?
No.
It makes it much safer, doesn't it?
Yes, it does, but we don't have it.
Oh.
So that's
that's it.
basically it. That's the end of the thing.
And you talked about materials before, so steel obviously comes off in a string. Is
Yes.
that because brass is it brittle?
Brass is brittle and it breaks off in chips.
Right.
If you're using steel or aluminium comes off in a stream
Yeah.
as well. Which again, they're very sharp. The brass tends to be less sharp, although it can still get you, and it can still have sharp edges to it, and it gets caught under your nails and all kinds of stuff like that. So I really recommend taking care with it equally.
So where's the USB port on it anyway?
Well, yeah, it's
Yep.
up to you.
Yes, I can.
What software do we use?
I was going to say, yeah,
Bluetooth?
yes, it's Bluetooth enabled. Yeah,
Well done, Kevin.
right. So that's pretty well. Oh, it's playing again. Hang on. How do I get to the next one? Must be a way to get to the next clip.
You can, if you at the bottom of the page, that thing down there, yeah. Is that doing it?
No, not done.
Okay, escape then.
Okay. Here we go. It's appeared. Right. So, when we get to the next bit, we have got in the end of this thing for those who can't work out the operations. There are a few clues within this. Now, this is a way of making it. I do not guarantee that it's the only way to make it. Part of the questions on this, when you get the sheet, one of the things you have to do is write on the back of it all the operations you need to make it
Before you start,
before you start. Because
before you start the test.
you have to think about how you're going to make this, because otherwise you're learning to do something, and then what you're going to do with it, if you can't break down your design in the future, you're never going to be able to use the skills you've learned. So sorry to be cruel to you. There is help with that if you need it, but basically, if you think about it, there aren't that many operations. You know, there's obviously you've got to get it to the right length. You've got to do the bit on the front. You've got to do that bit, and there's knurling and cut it off and various bits. So it's just a question of working it out.
Or watching the video again.
Or watch the video again. Yeah.
And
Or,
making notes.
or make notes. Exactly. Well, to be honest, all the steps are here in the end of this if you're really stuck. But most people can get close enough just by thinking it through into the operations, just taking each piece and working it through, you know, looking at a solid piece of art. The trick to remember is that you need to have the pieces to come off of a single solid piece. So we put in a long piece and you cut it to the bits you want. The reason for that is because trying to hold that little tiny bit while you did that would be almost impossible. So that's it.
Excellent.
So, any
I think